Bismillahirrahmanirrahim. So today we will discuss about the very last topic of this chapter, which is transformer. Okay. So in the previous classes we discussed about motor and electric generator, right? And mainly we discussed about AC generator, okay, as it is in your textbook. So before I start discussing about transformer, I want to ask, do you have any doubt from these two topics, motor and generator?
No, sir.
Acha, okay. So let us start discussing about the transformer. Okay. Now transformer, the name is self-explanatory itself, right? It transforms something. Okay. So what does it transform? It transforms the voltage. Okay. So whenever we are talking about transforming, there can be two types of transforming. Okay. Either I will increase the voltage, I will transform into something bigger, or I will transform into something smaller, right? So there is step up and step down. Okay. So the two types of transformers are there: step up and step down. So whenever we want to increase our voltage, we want to give a smaller input, but we want a bigger output. Then we will be using step up transformer, and when we will be giving a larger input and we want a smaller output, then we have to use the step down transformer. Okay. Now mainly the electricity, this is generated where? In the power stations, right? And from the power station, these power stations are miles away from our home, right or wrong? Now from the power station, it is actually the through heavy load wires, it is transferred to the, it is carried out to the substation. From the substation, it is delivered to your home. Now in the substation, there are transformers. Okay, the current that actually comes from the power station are of large voltage, right? Okay, now in substation we use the transformer uh, because we want to supply the electricity with such a voltage that will not cause any damage to any electrical appliances that we use at home. For example, I will give you a personal example. Okay, actually I suffered a lot because of this. Once my uncle, who lives in I think he was in Bahrain, I guess, that time. Okay, now he is in Italy, but then he sent a laptop for me. I forgot actually where he lived, either Dubai or Bahrain, somewhere in the Middle East. Okay, so he sent a laptop for me, and that laptop was actually generated in UK. So in UK, they use the line of 110 volt. Okay, the voltage they use for household electrical appliances to run is 110 volt. So the laptop was made according to that. Okay, but in Bangladesh, the electric lines are of 220 volt. Okay, so as a result, what happened when I used to charge my laptop through the charger, there in the laptop charger there is an adapter. There is a black box. Every one of you might have seen this. So what used to happen? It used to get very hot. Why it used to get very hot? Because more amount of current is passing, more amount of current is passing through the wire that it can tolerate. It is made according to the connection of 110 volt, but I am connecting it to 220 volt line. So as a result, as the voltage difference is higher, more current is flowing, and as a result, more amount of heat is being generated. Then suddenly one day, what happened? It caught fire. Okay, it got heated so much that it caught fire. The wire that was connected to the adapter got burned. Okay, so you understand the safety that we have to maintain, right? Okay, so not the voltage of the current that is coming from the power station is not always suitable to use in every home or to run the appliances, right? So in substation we have to use transformer so that we can make it suitable to supply the current to the customers, right? So this is the importance of transformer actually. Now let us try to know what does step up does and what does step down does. I already told you that a step up means transforming a lower voltage into higher voltage. Okay. Now how we do that? The device is actually made of iron core. Okay, iron core. Then in these two opposite side we will be winding wires. Okay. Now while we are winding wires, two things can happen, right? The wire in which we will supply the voltage, where we will supply the voltage, will be known as primary coil, and from where we will get the output, it is the secondary coil. Okay, same goes here also. So here Vp, this is the voltage difference at which we are supplying the electricity. Okay, so what will happen? We will be getting a different voltage here, because can you guess what is the difference between these two windings?
Coiling একটা মধ্যে বেশি একটা মধ্যে কম.
The difference is number of winding. Okay, you can see that less number of winding is there, and here more number of winding are there. We already got to know from electromagnet, if you remember, that if the number of turns are more, okay, then what will happen? Much stronger magnetic field will be generated. Why? Because the voltage increases, right? So when you will supply voltage here, as it is within the range, what will happen? It will induce an voltage here also, and this voltage will be according to the number of turns that you supply. There is a relation between voltage and this number of turns. I will be discussing about that shortly, but let me discuss the basic things first. Okay, so in a step up, what we have to do: in primary coil there will be less number of winding, and in secondary coil there has to be more number of winding. Okay, and then in a step down it will be just the opposite, because we will supply larger and we want a smaller. Okay, so in the primary coil the number of winding will be higher, and in secondary coil it will be much lower. Okay, now what is the relationship between the voltage and this number of coil? It is directly proportional. That means if you double the number of turn, then what will happen? The induced voltage will get doubled. Okay, so we can write dP by ds is equal to np by ns. Now I hope you already know this proportional type of relationship, right? See, if I write V1 by V2 is equal to N1 by N2, you can see that 1, 1, they are at the corresponding position, so it means that they are directly proportional. But if the relationship was inversely proportional, then I would have written it in this way. Okay, then the corresponding will be in the cross multiplication direction. Okay, Achha. So this is the relationship, and this is the equation we are going to use to solve numerical problems. Okay, out of this 4 quantity, 3 will be given, and another one you will have to find out. Or sometimes it will happen that the relationship between NP and NS will be given to you, and using that you have to find out PP or PS. Okay, they might not give you the direct answer. Like they might tell you the primary coil consists of twice the number of winding of the secondary coil. That means primary coil winding consists of twice the number of winding of the secondary coil. Okay, from here actually we can directly get the value of NP by NS, that is equal to 2, right? So even though you do not know how many windings are there in secondary coil and how many windings are there in primary coil, still you don't need to know, right? Because directly you can put the value of this here is 2, and dP by ds is here. One out of this 2, one will be known, another one you can easily find out, right? Okay, this is just a heads up. Then this is one equation. Another equation that we are going to develop is which will relate the voltage with the current. Okay, the voltage with the current. Now we know from work over energy chapter, we have already studied the conservation law of energy, right? Energy can neither be created nor be destroyed. It can only be transformed from one form to another, right? Okay. Now the amount of energy we will supply here, the same amount of energy will be induced here, right? So the energy induced will be same, because energy you cannot create it. Okay, so energy will be same. So now how to calculate the energy? If you remember in current electricity chapter, we used to calculate the amount of energy used, electrical energy used, right? Based on that we used to calculate the bills. If you remember, there were several equations. The equations were W is work done and energy, they both mean the same thing. Okay, so that was VI T Then there are several more expressions were there, right? From there, we could have calculated the power also. P is equal to W by T. So it will be VIT by T. So equal to VI, right? Remember? We used to
Yes, sir.
calculate the electrical energy based on kilowatt hour. Okay. So according to that, what we can write, if the current flowing through this is IP and the current induced here is IS. Remember, I'm saying inducing. This is related to electromagnetic induction, right? So definitely, if you flow current to here, here also some current will be induced. Okay. So IP IS, this is IP and IS. So the relationship will be like this: dP IP will be equal to ES IS. Okay. Okay. So from this relationship, actually, if you know the any three quantity, then what you can do, you can find out the other quantity. Okay. Now in your book, let me check whether there is any example or not. One example I found out, the number of turns in primary coil of a transformer is 100. Number of coil in primary coil, sorry, that is NP, right? NP is given as 100. Then the number of turns in the secondary coil is 1000. Secondary coil 1000. Looking at these numbers, we can easily say whether it is a step up or a step down. Can you tell me what is it? Step up or step down?
Step up.
Step up, very good, because primary take secondary take number of turns beshi. Then 12 volt AC is applied in primary coil. Primary coil, right? So VP 12 volt. Definitely we have to find out the voltage in secondary coil, PS. So we saw our equation a little bit ago, applying which we can actually calculate this. Can you do it yourself, or should I show the calculation?
Yes, you can do
You
it.
can do it.
Okay, easy, right?
Yes,
So
sir.
the
Yes,
questions
sir.
from the transformer is very easy. So with that, actually, we have completed all the topics of this chapter, magnetic effects of current. Okay. What I would like to tell you is start solving the creative that are in the suggestion book. Okay, magnetic effect of current. You have been given a suggestion book in which there are several creative, and solving creative will actually make you more confident. So kindly go through those creative and let us fix a date within which you will actually complete solving all those creatives and come up with the doubts. Okay, can we do this?
Yes, sir.
Inshallah.
Okay, so we can actually do it in two ways. Okay, let us say today is Tuesday. Okay, we can fix Thursday. Okay, or we can fix tomorrow's class. I don't know when I have a class with you next. Okay, whenever we have class next, till
Thursday.
before that, if you complete the first 10 creative, and in the following class, if you ask me doubt from this 10 creative, then I can discuss about that. Then before the next class, you will solve another 10 creative and you will ask me doubt from that. We can do like this, or we can do like this, that you will solve all the creatives together and you will ask me all the doubts together. Which one seems convenient to you?
The first.
The first option or the second one?
First one.
First one means first one.
Like 10 critics before your class.
Oh, a 10 creative each class. Okay, fine, no problem. How many creatives are there? Can you check and let me know, so then I can guess in how many days we can complete it. You have the book, right? Somebody has the book available near you. Or due to the vacation, you might have not seen it for last 2-3 months and you don't know where it is. There is a possibility that your mother has thrown out the book and given to the garbage man. Possibly.
Sir, they will throw us, but not the book.
Oh, nice, nice.
বুক ফেলতে হাত কাঁপবে না, বুকের যদি আবার বদয়া লাগে?
হ্যাঁ কি ইমন?
বুক ফেলতে গেলেও ভয় করে না? যদি বুকের বদয়া লাগে, বইয়ের বদয়া লেগে যায় তাহলে ফেল করে যাবো না?